Let's have a look at question 4 in this video. So we have data regarding how many hours teenagers watch TV and how aggressive they are. Now this study used a random sample of 707 teenagers. Out of them, one group of 88 teenagers watched TV less than 1 hour a day, and the other 619 teenagers watched at least 1 hour of TV a day. The 99% confidence interval for the proportion of teenagers who watch TV less than 1 hour of day is the following. So let's understand the intuition. Why do we have this confidence interval to begin with? Now, this is gonna be the proportion of teenagers that watch TV less than 1 hour of day. 88 people out of 707. Let's see what ratio that is. X1 is gonna be 88. Sorry, not X1, but P1. The proportion of the first group that we're estimating based on the sample, this is sample data, is gonna be 88 out of 707. That's equal to 12.4%, which is the same as 0.124. Now this is just an estimate of this proportion in the population. They're not equal. So we want to know what's gonna be a range of values that's gonna contain the proportion of this group in the population with a 99% probability. This is the same logic, the same analogy with all the confidence intervals in other tests. So what are going to be that confidence interval? This is based, the confidence interval for the proportion in the population is going to be based on the proportion that we found in the sample. So that's going to be P1 based on the sample, meaning we're using the hat, plus minus the critical value Z, because we're using here very large observations, we're using the Z critical value, and also in proportion testing we're using the Z values, so that's why we're going to use the Z critical value here. The Z critical value at the 99% confidence interval, so that's going to be 1% significance level spread over 2 tails, and then multiplied with the standard error, and the standard error in this case is going to be equal to the proportion that we found based on our sample, so that's P1 hat times 1 minus that proportion divided by the number of observations that we're using to get our data from. That's equal to 707. So that's divided by n. Now with that said, we can substitute all the values and find out this confidence interval. Let's do so. That proportion we just discussed, that's equal to 0.124 plus minus the critical value Z is equal to 2.576. We can find this on the row in the table D distribution. They're given there in the last row. Those are the Z critical value depending on various significance levels. And over here we have to substitute some numbers. So we're going to have 0.124 and 1 minus 0.124. By the way, these are rounded up, so you might have slightly different, but the point is the same, the logic is the same. 1 minus 0.124 is going to be equal to 0.876, and n is equal to 707 observations. Now it's a matter of doing the math over here. So if we solve the math, we would get the following confidence interval. It would range between 0.092 up to 0.156. And what we can see in the answer key, they have slightly different. So the answer to this question is false, and we are done.